everybody understands, please don't please don't take the chapter 9 or chapter whatever test, the last test yet. Y'all still got homework to do. And I'll probably take off the 4.1 and 4.2 homework. So I want you to concentrate. Hold on. I want you to concentrate. Has anybody worked on the 4.1 and 4.2 homework? Anybody?
I have, Hubert, a little bit.
Okay, was it, which one, 4.1 or 4.2?
I done a little bit of both of them.
Okay, what did they have in them? Was it mostly Riemann's and review of what we've done, or what?
Hold on, I can pull it up right now and tell you.
Okay, anybody else want to throw it in the conversation?
It was kind of what we done last class with defining the integral.
Okay.
It was the problems that we went over last class.
Okay. What, 4.1 or 4.2?
4.1.
Okay.
They're kind of mixed in.
I think I'm going to cut out 4.2 because 4.2 is Riemann's. And Riemann's is just a long way to do integration. It's kind of like, you remember us doing the different quotient? Y'all remember us doing the difference quotient? And then I showed you okay, that's the same thing as the integral or the antiderivative to Riemann. Riemann is the long way of doing it. Okay, so I'm going to concentrate on the test 4.1 and 4.3 on basic integration. Basic, that means definite and indefinite integration. So the problems that I showed y'all, Tuesday, all of those problems will be on the test, or problems like that. What I'm going to do today is a continuation, just basic integration. I'm not going to do any word problems. I'm not going to do any, it's just going to be 10 or 15 questions on basic integration. And that test will be called Unit 4, last test. And I will have it up this afternoon, okay? Sometime this afternoon. And we'll replace the one that's on there now. Some of y'all actually took and didn't do well. All right? And it will be due the same day as the final exam. Somebody tell me how many attempts on the final exam?
Is it 2?
2. And what do I do? Average a grade or take the highest?
Take the highest.
Okay. And probably 30. I think 25. I haven't looked. Some of y'all have. If you want to share with the class how many were on the test, I'd appreciate it. But you have 2 hours to take it. And you know the dates. The date. There are 30. Okay, thank you, Miss Holcomb. Did you do good on it, Miss Holcomb, or did you take it? I hope you did good. All right, 2 hours. You got about 30 questions. And, oh, you just went in and looked. Oh, my gosh. You mean you actually went to MyLabs Plus to get information about the test? Wow, what a concept. Better just to email your teacher with 15 questions than to go to MyLabs Plus and actually look and see all the stuff that's given before you even take the test. Anyway, and you have a date. The date is in MyLabs Math, so if you want to look at the date, you can do that. Okay, does anybody have any questions about, I will put a new, it'll be called Unit 4, Last Test, Revised. Okay, does everybody understand that right there?
Yes, sir.
Now, if I see a grade that's decent, some of y'all went in, I haven't looked at it since Tuesday, but if somebody went in and took the Unit 4 test and made a 70 or better, I'll keep that grade. I don't know why you'd want to keep it, but I'll keep it. Anything below 70, I'm going to delete it. Does anybody have a problem with that? If you do, let me know before class ends. Because a Tuesday, 5 people tried to take it and they all made below 70. So, all right. So let's go. Let's go ahead and get to some problems. And I'm not going to kill myself. If I get over 3 problems today, that's great. If I don't, that's great also. We're not trying to kick y'all while you down. All right, I want you to let's do A. That's a good test question. So I want you to do A. I'll write that one down on my handy dandy whiteboard. A is the antiderivative from 2 to 4 of 2x to the third minus 3x dx. And I'll write down B on another one. B is the antiderivative from 0 to the natural log of 4. And all that is a number, so don't start running around in circles because of that. 2e to the x dx. And the antiderivative of e to the x is e to the x. So you ain't gotta do much brain work there. And the antiderivative of 1 to 5 of x minus 1 over x dx. All right, I've got them all written down. I want you to go ahead and start working on that first one. That first one and the second one you should be able to do without any problems. Okay? So go ahead and work on the first and the second one. And I'm going to move this out of the way. And here is the first one. Now, I'm going to show you the simple way to do this. It might have extra steps for those people that invented calculus. Okay, those people that think they know everything, you're not going to do as many steps as I am, but I'm not here to teach those that know everything. I'm here to teach those that suck at it. So I'm going to write every step. So here we go. I'm going to take the antiderivative. I'm going to rewrite this as 2 antiderivative from 2 to 4 of x to the third dx minus 3 antiderivative from 2 to 4 of x dx. Now, the reason I did this is so you wouldn't freak out because of this, all right? Since this is a minus or a plus, you can break this up into 2 different antiderivatives. Capiche? Now, if you don't want to do that, that's fine. But I just wanted you to know that you could do that. This is 2 and times x to the what? 4th over 4 minus 3. This is x to the first, so that's going to be x to the second over 2. Now, if you don't remember from last week or from Tuesday, how you do the derivative is x to the 1 plus 1 over 1 plus 1. And this one is x to the 3 plus 1 over 3 plus 1. Okay, so that's the middle step that I skipped to get to this step. And now that's all evaluated at 2 and 4. So now what happens here? Does anything happen here? That means I want y'all to communicate. I can't get my stuff to work right. I have to look at the conversation because the only people that will communicate with me are in the conversation. Miss Holcomb and Mr. Schmidt. Thank you so much. And that will be a 2, and nothing happens here. So our evaluation expression is x to the 4th over 2 minus 3x squared over 2, evaluated at 2 and 4. Now, I want to make an announcement here. There are some people, some instructors, that will take this as an answer. Has anybody ever had a pre-calculus instructor or a calculus instructor that just says, give me the setup? Anybody?
I haven't.
Me the setup. Write that down, because when you're reviewing this in Calc 230, they may say, the directions just say, just give me the setup, or what is the setup? This is the setup. Because what is the rest? What subject of mathematics is the rest of this problem? Basic math, pre-algebra, basic math. A calculus teacher is not going to judge you on whether you can work a calculator or do basic math. Is everybody with me? So some calculus teachers just say, give me the setup. And some of your homework problems will just ask for the setup. May not in 130, but they may ask you for the setup in 230. Does everybody understand that? I hope everybody writes that down, because I don't want you to be confused when you go into Calc 2 and the teacher says, just give me the setup. Okay, now we're going to do the basic math. So I'm going to go to a white page. And sorry, I got all the, and we're going to do this. So I'm going to rewrite it as parentheses to the 4th over 2 minus 3 times parentheses squared over 2 brackets minus parentheses to the 4th over 2 minus 3 times parentheses squared over 2. And yes, if you was to come into my office today or 3 years from now and say, Hubert, I can't do this problem, would you do it? Would I do this? Yes. Not because I'm trying to teach you how to do a problem, because that's the way you should do it. Unless you're one of these people that are, divine intervention and, you can walk on water. So plug in a 4 here and plug in a 2 here. And that comes from these guys. 2 there and a 4 here. Y'all have to excuse my page flying everywhere. I've got all my fans turned on. I'm still waiting for Dogecoin. Dogecoin hit 32 cents, 33 cents. So I'm trying to wait for it to get to $1 so I can buy me a whole new air conditioning system.
Hubert, I have a quick question.
Yes.
Do you know if they're offering 230 over the summer online?
I can't say. I can answer that after class when I'm not recording.
Okay. I got your drift just from that statement.
I don't think you're gonna get it offline.
Okay, I got you.
We have some teachers that will spend their entire semester trying to catch people cheating. And that's ludicrous because 10% of my class and any class is going to cheat. Am I ever going to stop students from cheating? No. Okay. So I put Hubert's focus on the 90% that's, they want to learn and do what they're supposed to. Some of my colleagues believe they should spend 90% of their time trying to catch people trying to cheat. Everybody with me?
Which is nearly impossible to do on an online class.
Exactly. Well, anyway, they make everybody come to class. They make all the students take tests and the testing center and all that kind of stuff. So I think I just answered your question.
You did. Thank you.
Mm-hmm. That's why I don't teach 230, because I think that's ridiculous. I think, 10% of my students are going to cheat. I know that. But I don't worry about them. Why? Because when they get in the real world, they're not going to know how to do anything. And what are they going to do? They're going to end up using the people that they work with to do their work for them. And is that going to work in the real world? Hell to the no. So here we go. 4 to the 4th power is what? Well, 4 to the 3rd power is 64, right? So 64 times 4 is 256. Somebody check me, please. What's 4 to the 4th power?
Yes, 256.
Divided by 2 minus 4 squared is what? 16. 3 times 16 is 48. Two to the 4th power is 16. So that's 16 over 2, I think. I hope. 2 times 2 is 4. 12 over 2. And yes, I know I got a degree in everything. I know that you can divide these, and that's good. I'm glad you know that. So that'll be what? 128. I hope this is 128. Minus 24. Minus 8 minus 6. Please check my basic math, please. 128 minus 24 is 4, isn't it? Minus 2 is 102. So, what did we just find? We just found, let's take our handy dandy calculator. Y is equal to 2x cubed, 2x cubed minus 3x. Graph. Zoom standard. Okay, so we've got a curve that looks like this. Okay, and let's see what that x-intercept is right there. Oops. I don't want that. Oh my God, hold on a second. Stat plot off. There, graph. And trace. Where in the heck is my little cursor? Thank you for cooperating. All right, so that's about what, 1.8, so 2, yeah, we're good. 2 is going to be, okay. So 2 is going to be right in here somewhere. So let's say that's 1, that's 2, and that's 4. So we just found the area under this curve, and that is 102 square units. Cool. There is the basic math. And there is the setup. That's a good test question. Okay, so let's do a e to the x. There you go. E to the x. Now the good thing about e to the x is the antiderivative of e to the x is e to the x. So that's a good thing. So antiderivative, so this is 2 antiderivative of e to the x from 0 to 4 dx. Well, the antiderivative of e to the x is e to the x. So you need to write that over here on the right. The antiderivative of e to the x is equal to e to the x plus c. So 2 times e to the x evaluated at 0 and natural log of 4. And that's going to be 2e to the parentheses minus 2e to the parentheses, which I already plugged in as 0, sorry, natural log of 4. And this is going to narrow down to 2 because e to the 0 is 1. And e to the natural log of 4. So calculator. E to the natural log of 4 is 4. So 8 minus 2 is 6 square units. Sorry, hold on. Question, gripe, complaint. And you could graph that too. Y is equal e to the x. And delete, delete, delete. I hate these calculators. Second, e to the x. When you hit delete, it's supposed to delete from that point to the right. For some reason, this new calculator, when you hit delete, 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 it deletes back like a backspace. Damn Russians. Graph. There it is. And they want from 0 to the natural log of 4, which is 4. So 0, 1, 2, 3, 4. So up here, all this area right in here is 6 square units. Question on that one, and that's a good test question. I'm not going to sit here and tell you that I'm going to give you a bunch of 5 or 6 step and antiderivatives on the last test. One, if you notice, you only have 3 sections of integration. It's not that important for 230. but you have to understand the concept of antiderivatives. So that's why I'm only hitting, the area under a curve. I keep showing you all the area under a curve so you'll have a good introduction to it. Not that you can build the space shuttle, okay? You just need to have an introduction. It's called common sense. All right, here's the last one for the 3 that we were doing. Now this one, be careful because you're not, just be careful because you're not going to do what you think you're going to do here. Let me tell you this. The natural log of x is involved with this one. I would suggest that you break it up into 2. You might want to break it up into 2. No, you can't do that. Well, yeah, you can. You can break it up into 2. That's what I would do. I would rewrite 1 to 5 x over x minus 1 over x. Okay, do that. That'll help you out a little bit. So antiderivative from 1 to 5 of x over x dx minus antiderivative from 1 to 5, 1 over x dx. And I will tell you right here, and if you think about the derivative, if f of x is equal to 1 over x, f prime of x is equal to the natural log of x. Okay? Or I just wrote the antiderivative. I'm sorry. I just wrote the antiderivative. So let me just write it. The antiderivative of 1 over x is equal to the natural log of x. Because the derivative of the natural log of x is 1 over x. So the antiderivative of 1 over x is the natural log of x. So that's the rule that you need to remember. So this is the antiderivative of 1 dx minus the antiderivative of 1 over x dx. Now I'm putting every step in here because you need it. Some of you need it. And this is x, and this is the natural log of x. Because what's the antiderivative of a constant? X. Because I'll show you here on the next page. When in doubt, always fill in. Antiderivative from 1 to 5 of 1x to the 0 dx minus antiderivative of 1 to 5 of 1 over x dx. I just rewrote it. I rewrote it with the x to the 0 because now you can do your law. I'm going to do the law right here. 1x to the 0 plus 1 over 0 plus 1. And this right here is the natural log of x. So if you put these two, simplify this one and bring this one down, you're going to get x over 1, which is x, minus natural log of x evaluated at 1 and 5. And I want y'all to do that. Parentheses minus natural log of parentheses minus parentheses natural log of parentheses. All right, plug and chug. Okay, so you're going to plug in a 5 and a 5 and a 1 and a 1.
Priority 1 message coming in
So
on
that's
secure
going to
channel.
be a 5 here, and a 5 here, and a 1 here, and a 1 here. And I'm going to just put 3 dots. I got 2.4. What'd y'all get? I need somebody to crank it out and tell me what you got. Anybody? Okay, Miss Holcomb, thank you.
Yeah, I got the same thing.
Good. All right, so somebody tell me how many problems did we do? I can't even think. How many problems did we do Tuesday? Look at your notes. I think we did like 6 or 8 problems, but count all the antiderivatives that we did. That includes definite and indefinite. Just give me a number from Tuesday.
Mine's kind of out of order, but I know we did probably at least like 6 or 8.
Okay, good. Okay, plus 3 today is 11. So I'm just trying to think, because I'm only going to give you like 10 problems on the test. So right now I'm looking through the, here's a good example of, here's a good example right here. I like this example. You can write it down. I mean, it's just showing natural log. That's a good one to write down in your notes. Well, where'd it go? There it is. The antiderivative of 1 over x dx. That's, you know, what is, it's a good picture on the next page. There you go. That's a good example right there of, now the way they have it written dx over x. I would not write it like that. You want to write it 1 over x and then dx to the side. But that's a good little picture and a short, sweet antiderivative of 1 over x. And it's very important that you write that, because you're going to forget that when you're doing homework problems. And I'm going to write it out here where I'm going to show it to you in just a minute. First of all, always write 1/4 dx over x. You want to rewrite that as 1/4 1 over x dx. And antiderivative of 1 over x, is equal to the natural log of x. Those two things you need to write down, and you need to kind of put it to memory right there. Because when you see something written like that, it's not going to register. All right. That's why I tell students to do this. When you see antiderivative of dx, no, that's going to throw you off. You rewrite that as antiderivative of x to the 0 dx, like that, because that 1 is sitting there like there. And if you write it like this, then you'll know, okay, x to the 0 plus 1 over 0 plus 1 is equal to x to the first over 1, which is equal to x. So if you see it like this on a test, just dx or dx over x, it might not register. So that's why I tell students to rewrite it. And then you can remember this rule. The antiderivative of 1 over x dx is equal to the natural log of x. And this one is just to rewrite, just in case you see dx just sitting there. Because when students see this, they'll either skip it or they'll put 0. They won't write it out. And I hope that helps. But none of you are going to say anything, so I ain't worried about it. Okay, so that's a nice little picture of what you're actually doing. Let's see if there's any other good questions in the slides. We already talked about symmetry, and we talked about this will be a negative area, this will be a positive area, but is this symmetrical? Yes or no? Is this symmetrical?
No.
No. So I want you to, well, I don't know where that went. It just went away. Okay, I'm going to draw this. I don't feel like working with the whiteboard on the laptop, so I'm just going to redraw this. And I want to show you something. If it's not symmetrical. Okay, so we got this coming down, crossing right there, crossing right there, and we got it going there and here like that. And you got this area right here, and you got this area right here, and you got this area right here. So I'm just going to do a quick little rundown for this. Okay, you got an area right here, and we're going to color that area. You know it's not symmetric. So not symmetric, and y'all got to tell me if I spell it. I always want to put 2 M's and 2 T's, and is that right, or is it supposed to have 2 M's? If it's not symmetric, it's not going to cancel. Okay?
I think it might be 2 M's.
I think it is 2 M's. Okay. If it's symmetrical, the areas usually cancel if it's around the origin. Okay. And this one is kind of going through the origin, just over this way a little bit. So let's say that this area right here, and I'm not going to go with the problem. Let's say that I'm just making this up. Okay, let's say that pink area is -5. Area, you do the math, and it comes out to be -5. And then you do the blue area or the green area, which is above the x-axis, which means it'll come out to be positive area. And it comes out to be +4. And then you do the blue area, which comes out to be, no, well, I didn't want to do that. Let me change the green area, change it to -3, I mean +3. And then the blue area is -1. So what is the area of this region? Well, that would be -5 +3 -1. And that's going to equal what? Well, -5 +3, you owe somebody $5. You give them $3, you owe them what? You owe them 2, Hubert. That's right, class. You owe somebody $2 and you owe somebody $1, you owe them what? So is there more area below the x-axis or above the x-axis? Well, the answer came out to be negative, so
Below.
there is more area below the x-axis. So when you have something that's not symmetrical, which this is not symmetrical, okay, as far as the regions, then you just do what with the areas? You just add them up. And the negative will tell you that you have more area under the curve because the area is -3. So that means that there's more area in the pink and the blue region than there is in the green region. Capiche? So you got symmetrical. Symmetrical means, hold on. Symmetrical means that if it's going around the origin, it probably will cancel if you add them up. If you ignore the signs, then they're asking for the net area. Okay, in other words, ignore the signs, and that would be 5 plus 3. So the area of the pink region and the green region is 8 square units. But the negative tells you that the 5 units is below the x-axis. So the net area, or the gross area, gross would be 8. The net would be -2. So there's more area in the pink than there is in the green. Now you can't tell that with my drawing because my drawing, it looks like equal. But on the actual slide, you can see that this area is way smaller than what? This area. Okay? So that's a little bit showing you. And if you do the math, you would have to take the antiderivative of each one of these and plug in 2 and 1, and that's what they're doing right there. And you would have to go from -1 to 1/2. Hold on. -1 to 1/2, and then from 1/2 to, hold on, 1/2 to 3/2, and then from 3/2 to +2, because that's where the x-intercepts are. At least, or yeah, the x-intercepts, and then the lower bound is -1, upper bound is +2. Okay? Now, if you did the whole thing together, it would come up like this. Okay? And they got -2 1/4. Now, see, I did it not to scale, and I got -3. So I wasn't far off. Okay? I just made these numbers up. This is the actual, and I want to leave that on the screen there for a second in case you want to look at it. There you go. So they took the derivative, the antiderivative right here, x to the 4th over 4, 3x squared over 2, and x. There it is. And they just plugged and chugged. This is plugging in 2. This is plugging in -1. And this is your answer. -2.25. And I just estimated and came out with -3. So that is a definite integral that you could do, on a test. So I'm going to leave that up for a couple of seconds. I just want you to get the, at least get the plugging in and write down the final answer, and then you can do the math on your own time. Yeah, Dogecoin is going to stay around 31 cents. God, I wish it would get to 50 cents or $1. Well, what's his name? What's the guy that owns Tesla? What's his name? Elon Musk. He's going to be on Saturday Night Live. So they say he's going to, every time he says something about Dogecoin, it goes up like 10 cents. So I hope he spends the whole dadgum Saturday Night Live talking about Dogecoin.
I see where he's going to be on SNL here. I think it's going to be interesting.
Yeah, they say he's going to talk about it. I hope he does, because that's going
He
to be
said that he was
nation.
going to talk about it.
Huh?
He said that he was going to talk
Yeah,
about
he
it.
tweeted. He said, Doge God, or let's see, Godfather, Doge Father, SNL, May 8th. So if he just spends, 30 seconds talking about it, that'll send it up another 10, 15 cents. All right. So let's see what else they got for us. Okay, I'm not going to worry about doing a word problem. Now, I don't mind doing this. Let's do this. Let's do the antiderivative of this. Let's do that. I don't mind doing the actual mechanics, because that's what I'm going to give you on the test. So, antiderivative. Hold on a second. Let me get out of this and move this to my TV screen. Okay, antiderivative from 0 to 60 of the square root of x minus 6. All right, I want y'all to do that problem. This is another test question. Of course, you know why would I pick this problem? Somebody tell me why I would pick this problem for test.
We don't like it.
Huh?
We don't like it.
No. Well, you might, because Miss Holcomb's correct, because of the radical. Why would I pick the radical? Because radicals in calculus don't what? I've been saying it since the beginning of class. Thank you, Miss Holcomb. I ain't kidding. The Tide Pods must have gone to y'all's brains. Y'all better start communicating. Okay? Thank you, Miss Babineau. Don't mix. So I got to rewrite this. And you were right also, whoever said that. I couldn't see that light up about not liking it. That's good also, because students don't like radicals either. So that's going to be x to the 1/2 minus 6x to the 0 dx. And yes, I did that so you wouldn't screw the 6 up, because some of you might mess the 6 up because there's nothing there. And then you get confused and you start convulsing, and then you don't know what to do. So that's going to be x to the 1/2 plus 2/2 over 1/2 plus 2/2 minus 6x to the 0 plus 1 over 0 plus 1, evaluated at 0 and 60. Now I put that step in there for those of you that are scared to death of fractions and still a little bit rusty on figuring out how to do integration. So there you go. So this is going to give me x to the 3/2 over 3/2 minus x to the 1 over 1. And I'm going to take it up to the next page. And that's going to give me 2/3 x to the 3/2 minus x. Can somebody tell me what 0 is going to do to this problem? Oh, come on. Can't somebody say 3 words or 1 word? Thank you, Ms. Holcomb. 0 is going to cancel out, so I don't even have to plug in 0 because 0 minus 0 times anything is 0, so that's going to cancel. So all I'm going to do is type in 60. So 2/3, 60 to the 3/2 minus 60. And I don't care if you raise 60 to the 1.5 power and multiply it by 0.67. If you want to do that in your calculator, that's fine. I'm going to do it like this. Clear and clear. I'm going to take 2/3, 2 divided by 3, multiplied by parentheses 60 to the 1.5 power. Well, I don't know why I delete and parentheses. And I think that's it. 309.84. 309.84. That's for the first part. 309.84 minus I forgot the 6. 6 times, wait a minute. 6x. That'd be 6x. Sorry. 6x minus 6 times 60. Sorry. Appreciate y'all telling me that. Which is 360 equals, so 309 minus 360. Negative 50.16. Negative 50.16. So that means we got more area under the curve than we do above the curve. And if you look at this graph, x to the 0.5 minus 6, it's going to be horizontal shift of 6 to the left. I'm sorry, vertical shift of 6 down. Sorry about that. And you're not going to see it until you get to 60 at least. It's going to start, that's going to be a negative, yeah. From 0 to 60, it's all under the it's all under the x-axis. So it's going to be 0. It's going to be negative. Oh gosh, I can't think. Negative area. It's going to be right in here. Question, gripe, complaint. Are y'all mad at me or something? Y'all have talked to me all semester. Now you won't talk to me. I guess y'all just pissed at me for some reason.
We're just trying to soak it all in.
Okay, whatever. I'm looking to see if there's anything else. Okay, we just did that. That's just different numbers. I'm looking to see if they give us anything There's another one. You can write that one down. I mean, I'm not going to do it, but, well, let's see. How many are left? That's it. Okay, so we can do this one. Let's do that one. From 1 to 4, square root of t, square root of x, I don't care. Square root of t plus t. So let's do that. And somebody count up how many that, with this one right here, how many questions that is. I mean, you don't have to tell me right now. Just tell me before we finish the problem. So that's going to rewrite, because I don't like radicals. It's 1 to 4 of t to the 1/2 plus t to the 1 dt. And that's going to be t to the 1/2 plus 2/2 over 1/2 plus 2/2 plus t to the 1 plus 1 over 1 plus 1. So that's going to be 2/3, because this is going to be 3/2. So I'm going to 2/3 t to the 3/2 plus t squared over 2, or 1/2 t squared, however you want to write it, or 2/3 t to the 3/2 plus 1/2 t squared. So that is the answer. That's the setup. All you got to do is put evaluated at 1 and 4. That's the setup. So I'm going to go up here and I'm going to do the math up here. So 2/3 parentheses 3/2 plus 1/2 parentheses squared minus 2/3 parentheses 3/2 plus 1/2 parentheses squared. Six questions today, but how many did Miss Hollister say we had last week? 8?
Yes, that's 14.
Okay, that's good enough for a test. And plus, I ran out of slides. I mean, I could do, but I think 4.3 homework will be, but I want to show you one more thing, and I'm going to let y'all do this for homework. Y'all can do that. I'll give you the answer, though. The answer is 12.17. 12.17 miles. So write that down. 12.17 or 1666. Okay, I wanted to show you something out of 4.2, and the reason I want to show you right quick Riemann, and the reason I'm going to show you Riemann is because you can do some of the questions with Riemann and some of them with, but I'm not going to. Riemann is, there's Riemann. Either you have the triangle discrepancy on the outside or you have it on the inside. And what you do is you get the midpoint of 100 and 200. You get the midpoint, which is right there, and you multiply the midpoint times f of x. So the midpoint of 100 to 200 is 150. So that would be 150 times f of x, 250 times f of x, 350 times f of x, 450 times f of x, or you would do the midpoint, which would be 50. I'm sorry, 50 times f of x, 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 50 times f of x. Okay, and that's what you would do right there. And they're adding them all up right there. All right, that's one way to do it. And you see now they're breaking it up into smaller ones, which are 50, which that's what I did just now. You multiply 50 and then you would multiply by 50. And each one, now you break it up to 25. And remember me showing you the hairline? The hairline is what we want. And that's what we're doing with the derivative, the antiderivative. We're not doing Riemann because Riemann takes too what? Takes too long. You start with 100, 100 times this, 100 times that, 100 times this, 100 times that. And then you say, well, that's too big, so I'm going to drop it down to 50. Well, that's still too big. I'm going to drop it down to 25. Well, instead of doing Riemann's sum 2 or 3 times, what can you do? Do the antiderivative, which says I'm going to take my rectangle down to the width of a hair using infinity and algebra. So that's what you do. So technically, they're going from what? 0 to 600? And what is the function? I know there's the function right there. So I want everybody to write that function down, and I want you to go from 0 to 600. And technically, you're doing Riemann's theory, except you're just cutting to the chase. So I'm going to write it down. F of x is equal to negative x squared. Nobody write 600x minus x squared. Negative x squared plus 600x dx. I want you to find the antiderivative of negative x squared plus 600x dx. And I want you to give me the area between 0 and 600. Now, they use 6 or 8 slides to do this problem. We're going to do it in one page. So I'm going to let y'all do it. I'll join you in a second. I hate when stocks consolidate. That drives me crazy. Okay, so negative, I'm going to skip a step here. Negative x to the third over what? 3 plus 600x squared over 2. And that's going to go down to negative x cubed over 3 plus what? 300x squared, evaluated at 0 and 600. And what will the 0 do? I need somebody to either say it. Thank you, Miss Holcomb. Miss Holcomb, you're not going to have a nice office. You're going to be the dadgum CEO. Communication skills is real good, even though your camera don't work, or you say it don't work. All right. So I'm going to do negative x cubed over 3 plus 300x squared evaluated at 600. So that's going to be negative 600 cubed over 3 plus 300 times 600 squared. I was wanting to see if they, that, I don't think they actually did it, did they? Yeah, they got a big BA number, so it's going to be a BA number. So this 600 over 3, I don't think that's really going to matter because that right there is going to swallow it up because that's 300 times 36. Oh gosh, that's going to be 4 zeros, which is 360,000. Okay, so that's going to be 300 times 360,000. That's going to eat that up. But anyway, let's go ahead and do it. That's going to be negative 48. Let's see, negative 600 cubed. So parentheses, let's clear that. Clear, 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 negative 600, oops, cubed, divided by 3. So that's that, plus parentheses 300 times 600 what squared? I got 36 million. Y'all check to see if that's what y'all got. And let's look at their answer. Would you expect their answer to be more or less? Now this is, I'm going to ask somebody to talk here. Would you expect theirs to be more or less with their, this is our hairline box versus a box that's 5 feet wide or 10 feet wide?
More.
Their area, well, ours is more accurate. Their area would probably be, well, if you take the canceling out, it would be less. Okay, because they take the triangles out. Let's see, I don't know. Ours is more accurate. Yeah, theirs is a little bit less. Because when you take out, look at here, these are more, right? This is more area. This is more area than you need. What is this? Less or more area? Okay, I need somebody to say something. Less. So these technically cancel out what? These. So that's why this one is going to be less and less accurate. It's going to be less accurate. So theirs is 35,750. Ours comes out to be 36 million. The hairline is a whole lot more accurate than the box that is what? 25 or 100 feet or 50 foot wide or whatever. The hairline is a whole lot more accurate. So you can actually, you know, I'm not going to ask you to do Riemann because Riemann takes what? Takes too long. So just probably skip 4.2 homework because I'm going to omit it. Everybody understand that?
Yes,
and
sir.
I'll probably leave 4.1 and 4.3 open. Okay, so let me go and do that right quick. 4.1 and 4.3, I'm going to get y'all to watch it so y'all don't ask me 15,000 questions. Okay, so I'm going to go and I'm going to take out 4.2 on the homework. That's why I tell students not to go ahead of me. 4.2, where in the hell is the homework? Oh. So I'm going to unassign 4.2. And I'm going to go to the grade book. I'm going to take that out of the grade book. So y'all won't ask me about that either. Because I know what y'all do. Y'all get in this Hemi stage that y'all are in right now, and y'all go crazy asking me about stuff and me, and I don't want that. So I go ahead and chop it off before it gets big. Let's see. 4.2. I've already taken it out. Omit. Oh, I unassigned it. So I got to distribute 4 points. So I'll put 2 here. That'll be 6 and 6 there. So that should equal 200. Yep. Okay, now the only thing I need to do now, I wish I could go in and change the test, but I can't do that because somebody has already taken the test. So I've got to go in and I've got to remake the test. So I'm going to go in and I'm going to unassign this Unit 4 test. And I'm going to copy it. I'm doing this so y'all can see what I'm doing. And I'm going to call it revised. I'm going to put 4.1 and 4.3. 4.1 and 4.3. And next, and it probably is already 4.1 and 4. No, I did. Okay, I've already done it. So I don't have, okay, I don't do 4.4. So let me take those out. 4.4, 4.4, 4.4. We used to do, because the semester's short, that's why we didn't go to 4.4, which is important. 4.4 is just as important as 4.3. And take out 4.2, 4.2, 4.4. Hopefully y'all understand what I'm doing. I'm fixing to remove all of 4.4 and 4.2. I don't see any. Okay. 11 questions. Y'all think y'all can handle that?
Yes, sir.
Yes, sir.
Somebody will bitch about it. Now I need to change. Now, one more thing before y'all leave. And I'm going to change one more thing. I got to change the weights. So that way everybody will be set. And then y'all can ask any questions that y'all got after I do this. So I'm going to take this one out. And that should 1, 2, 3, 4, 5. It should be. They should equal all 1, 2, 3, 4, 5. That should be 0, buddy. There we go. Okay, does anybody have any questions now? When you go to test now, go to main menu and you go to assignments and you just want to look at the test. Unit 1, Unit 2, review, Unit 1, Unit 2, Unit 4, 4.1 and 4.3, and final exam. I probably need to go through there and take off those, but I can do that after class. All right, who's got questions? Okay, I have one request. Mr. Wiggins, what's your question? Mr. Wiggins, what's your question?
My bad. So everything on my lab's math. I said it's due the 3rd, right?
If that's what it says,
All right, cool.
okay?
Yeah.
I have one request for all of you. This is a challenge. I want each of you to go to Rate My Professor, and I want you to rate all of your professors for future students. Okay? Now, I've been good to y'all. I've let y'all skate by with not being videoed every day and not talking to me. So I have one request, that you go to Rate My Professor for every one of your professors. If they're not on there, put them on there. There's a little button that you can put add instructor. Okay? And make sure you spell their last name right. Okay? That's my only request, that all of you do that so future students can read and please be professional. Don't get on there and say, this teacher's stupid, and spell stupid, S-T-O-O-P-I-D. Okay, don't do that, because then I just rather you not do it. All right, I would like for you to be professional, write 2 or 3 sentences that kind of summarize the class, and anything that you might think will help students in the future say, hell no, I'm not taking that student, or I'm going to get in that class, because it's important for future students. Okay? Anybody got any comments? Anything you want to say? Yeah, right. This class ain't gonna say nothing.
I'm gonna be honest, Hubert. You have the best my professor grade I've ever seen.
Okay, I don't want to hear about it. I don't want to hear about it. Please.
Have you ever
Don't tell me
looked
anything
at
that's
yours?
on it? I can't stand to look at stuff like that.
Hubert, you're the best.
Thank you. Y'all are a pretty good class too. For the
You
5 or
got
6
basically
people
a
that talk to
perfect
me.
rating.
What'd you say?
You have basically a perfect rating.
Be quiet. I don't want to hear that. You're gonna jinx it. Now somebody's gonna go in there and say,
Hey,
"Hubert's
man, you can make his
stupid."
head big.
What? Yeah, I've already got a big head. All right, y'all get out of here. Y'all have a good day, and it's been good knowing you. If you have any questions or anything, I'll be around the house, and I'll be at the Anderson campus Friday. But if you got any questions you want me to team with you with, just send me a team or text or an email. We'll get together, and you should be able to knock this last exam out, and last test or final exam, knock it out. And y'all have a great semester, and try to pick out, go to Rate My Professor and try to pick out a good 230 instructor. There's 4, I think, that are teaching 230 or 3, and there's 2 good ones. That's all I'm gonna say. Okay? But my Rate My Professor should tell you who those are.